Today we're going to be talking about bisectors in triangles. And the next two lessons are very vocab heavy, so make sure that, I know I talk really fast in the videos, but please make sure you're pausing the video on the screen and getting all that vocab into your notes, because the vocab is really, really important for stuff that we do later on and just in general for knowing what I'm talking about when I'm talking about different concepts and different problems. Okay, a perpendicular bisector. And it is exactly as it sounds. It is a line that is perpendicular to the segment at its midpoint. So it can be a line, it can be a plane. PQ here, this line is the perpendicular bisector. RS is a perpendicular, or I'm sorry, PQ is a bisector. I apologize, bisector. It's not perpendicular, there's no right angle symbol. Our S is the perpendicular bisector of JK because we have that right angle symbol there. Perpendicular bisector theorem. And again, I'm going to try and pause at the end of this slide, but make sure that you pause the video and write down the important information from this. Okay, perpendicular bisector theorem. If a point is on the perpendicular bisector, then it is equidistant from the endpoints of the segment. Okay, so C here, C is on the perpendicular bisector, then CA is congruent, segment CA is congruent to segment CB. And actually, I don't like what I wrote here at the beginning. If CD is perpendicular to AB and AD is congruent to DB, so I'm perpendicular and I have the midpoint, then we have CA congruent to CB. Perpendicular bisector theorem, I guess this is kind of the converse of that. I wonder why I don't have converse written there. If a point is equidistant from the endpoints of the segment, so if AE is congruent to EB, so if these segments are congruent, then that point is on the perpendicular bisector. Then CE is perpendicular to AB and AD is congruent to DB. So it's just the converse. First example. Find BC. Okay, so I have a perpendicular. I have D being the midpoint since those segments are congruent. So AC is congruent to BC. BC therefore is 8.5. In this case, find XY. So I have segments congruent and I'm perpendicular. Therefore, I know that XY is congruent to YZ, making this segment 6. Third example, find PQ. So we know we're on the perpendicular bisector since I have a perpendicular and S is the midpoint. So 3x plus 1 is equal to 5x minus 3. I subtract the 3x over. I add the 3 over. Now I've just solved for x. Again, make sure you're finding PQ. So I plug into And that is going to be equal to 7. Okay, this is one of those more vocab heavy slides. So you want to make sure that you are writing down all of this. This is really, really important. So when 3 or more lines intersect at a common point, the lines are called concurrent. So 3 or more lines intersecting at one point is a point of concurrency. The point of concurrency of the perpendicular bisectors is called the circumcenter of the triangle. The circumcenter is equidistant from all the vertices. So if P is the circumcenter, so this point here is the circumcenter of triangle ABC, meaning it's on the perpendicular bisector. So PF is the perpendicular bisector of BC. So therefore, BP equals PC. PE is the perpendicular bisector of AC. So therefore, a point on the perpendicular bisector is equidistant from the sides. So PC is equal to PA. PC is marked with 1. So I marked PA with 1. And PD is the perpendicular bisector. So PA is equal to PB. So then what that means is PA is congruent to BP is congruent to PC. Equidistant from all the sides. And this is key. Sometimes the circumcenter is inside the triangle. Okay? I can move those points around so that it is outside of the triangle. Okay? Again, pause the video if you need a few more minutes to write down this information. Angle bisector theorem. I told you this is really lots of vocab happening, lots of theorems happening in this section. If a point is on the bisector of an angle, then it is equidistant from the sides. So if angle DBF is congruent to angle EBF, okay, so I have a point on the perpendicular bisector, then DF is congruent to FE. Then this is congruent to that. Converse. If a point is in the interior of an angle is equidistant. So to be equidistant, you have to have a right angle here. Okay, from the sides of the angle, then it is on the angle bisector. So if DF is perpendicular to BD and FE is perpendicular to BE and DF is congruent to FE, oh, I almost had enough room there, then angle DBF is congruent to angle EBF. As always, take a minute to pause the video if you need more time to write this down. Okay, now finding some algebra, or now using some algebra. Find DB. I have congruent angle marks here. So therefore, DC is going to be equal to BD, which is 5. I have W. From W, I have a perpendicular to both edges of my angle, and I have a congruent mark, so therefore we know it's on the angle bisector. I need to find angle WYZ. This angle is 28, so that angle has to be 28. Okay, here, we know it's on the angle bisector, so we know QS is going to be equal to SR. So 4x minus 1 is equal to 3x plus 2. I subtract the 3x over. I add the 1 over. Again, remember you're finding QS, so plug in 4 times 3 minus 1, so 12 minus 1 is 11. The point of concurrency of the angle bisectors of a triangle is called the incenter. The incenter is equidistant from the sides of the angle. Okay, so let's talk about what that means here. So if P is the incenter, okay, so P is on the angle bisector of this angle DAE here. That means if it's on the angle bisector, it's equidistant. Those two segments are congruent. If P is on the angle bisector DBF, then PD and PF are going to be congruent. So we know that PE is congruent to PD is congruent to PF. And the incenter is always inside the circle. It's called the incenter because eventually in chapter 10, once we do circles, we are going to be inscribing a circle inside of that triangle. Again, take a minute to pause the video and write this down if you need more time. Okay, find ST if S is the incenter. Okay, so S is my incenter. If I remember, this one was a little bit more complicated. Okay, S is my incenter. Find ST. Okay, so I know that all of these segments are equal. I paused for a second because they didn't appear to be equal, but if S is the incenter, the perpendicular down to all of the sides of the angles are going to be equal. Okay, so I know SU is congruent to ST is congruent to SR. Okay, let's use this triangle here. We know that that's a right triangle. And hopefully you remember your Pythagorean theorem. 10 squared equals SU squared plus 8 squared. So I have 100 equals SU squared plus 64. SU is equal to 36. SU squared, I should say. SU is equal to 6. ST is equal to 6 because it is equidistant from SU is equal to ST. I know they may not look equal. That's a good way to show you guys that pictures may not always be to scale, or pictures may not always give you everything that you need. Find the measure of SPU. Okay, SPU. So I need to find the measure of this angle here. Okay, well, my way of thinking about this is if S is the incenter, then this angle is 31, this angle is 28. So I add those angles together, I get 180. So for the whole angle NPM, I get 62 degrees left over. SPU is half of that. So angle SPU is equal to 61 degrees. Okay, my last example here. Write the equation of the perpendicular bisector of the line through the points -3, 7 and 5, 1. And I love this example. I love this example because I like writing equations of lines. I like algebra. Algebra and we really get along. I do love geometry, but I just love algebra. So again, you're writing the equation of the perpendicular bisector of a line through those points. So let's find the slope of that line. 7 minus 1 over negative 3 minus 5. Okay. So my perpendicular slope is going to be 4/3. Now remember that your perpendicular bisector goes through the midpoint. I love this question. I love this question because it gives me the ability to test you on multiple things. So the midpoint of this segment is negative 3 plus 5 over 2. Can you find the midpoint? My midpoint ends up being, oh, I have it incorrect in my notes. I have a negative 1. 1, 4. Ooh, okay. So now I'm going to be flying off the cuff here. So, writing the equation of a line. So I can test you, in this problem, I was able to test you on, can you find slope? Do you know what the perpendicular slope is? Can you find the midpoint? Can you now use that and write the equation of a line? So building multiple pieces in one problem. 4 is the y-coordinate of our line. 4/3 is the slope. 1 is our x-coordinate plus b. So I have here 4 equals 4/3 plus b. I subtract 4 minus 4/3. And I get 8/3. So now I write my equation of my line. And there's your equation of your line. Again, I just love that problem. I think it's a really good use of multiple concepts that we've talked about all year. Okay, thank you for watching my very vocab-heavy video on bisectors of triangles.